Now we're going to do some examples of derivatives on vector-valued functions. We have two examples here, and we're going to perform a sequence of operations on them. So given this, t cubed I plus 2t cubed plus 3j plus 3t minus 5k, we want to find r prime, r double prime, r prime dot r double prime, and r prime cross r double prime. So let's do these examples. Now remember, the derivative of a vector valued function is simply the individual derivatives paired with their components. So t cubed I is going to stay 3t squared j. This is going to be 3t squared I, 6t squared j, and 3k. Right? So those are your standard derivatives. Now when we do r double prime, we simply take the derivative of r prime, like you would expect in a scalar valued function. So we have 6ti plus 12tj, and of course that's a 0. Now when we take r prime dot r double prime, we multiply those together, so that's 18t cubed plus 72t cubed, and of course that's 0, giving us 90t cubed. And then we want to compute the cross product. So to do that, we're going to set up the cross product the way we normally do and say I, j, k, I, j, 3t squared, 6t squared, 3, 3t squared, 6t squared, 6t, 12t, 0, 6t, 12t. And then we go across, so we get 0i plus 18j plus 36t cubed k minus 36t cubed k minus 36ti plus 0j. So we get negative 36ti plus 18j. And if we take that dot product of this with each of these, both of those dot products should be 0. That's negative 216 t squared. Hold on. So the j there should have been 18tj. So that's negative 216t squared, positive 216t squared. Similarly, negative 108t cubed, 108t cubed, and then 0. So we find our answer here, negative 36ti plus 18tj. All right, so then let's come do the same thing over here. R prime of t is going to be e to the t, 2t secant squared t. R double prime is e to the t, 2, and 2 secant squared t tangent t. Now you may not remember that off the top of your head. That's power rule. We bring down the 2. We have standard secant left multiplied by its derivative, which is secant t tangent t. So we have 2 secant squared t tangent t. And so when we take the dot product, we have those two together. So that's e to the 2t plus 4t plus 2 secant to the 4th t tangent t. And then when we take that cross product here, we'll go I, j, k, I, j. Let's give ourselves a little more room here. Because of that secant, let's give ourselves a little more room. I, j, k, I, j. So e to the t, 2t, secant squared t, e to the t, 2t, and e to the t, 2 secant squared t tangent t, e to the t, and 2. So then coming across here, we go down, we get 4t secant squared t tangent t I plus e to the t secant squared t j plus 2 e to the t k minus 2 t e to the t k minus 2 secant squared t I minus 2 e to the t secant squared t tangent t j. So we have all that written together. Now let's do a little bit of combining like terms. So we see we have a 2 and a secant squared t in common there. So we're going to have 2 secant squared t. So that's 2t tangent t minus 1. So that's your first element. The second one, we have an e to the t secant squared t in common. And so then we have a 1 minus 2 tangent t. And then we have 2 e to the t in common here. 1 minus t. So there's a lot that goes on here. We could take that, we can multiply this to make sure that the cross products do come out correctly. Not going to do that here because it's going to take a little bit, but this is the basics of doing derivatives of vector valued functions.